Hi everyone, welcome to the video lecture on partial differentiation. I'm Dr. Soni Pathak, Associate Professor in the Department of Basic Sciences, Chhatrapati Shivaji Maharaj University, Panvel, Lavur. Partial differentiation is one of the most important topic in the multivariate calculus. This has a wide application in mathematics, physics, heat transfer, fluid mechanics, as well as AI and economics. At the end of the lecture, you will able to learn define partial differentiation, compute first order and higher order derivative, partial derivative, understand and apply the chain rule for the function of several variables, apply Euler's theorem for smoothness function. Now, what is differentiation? Differentiation is a mathematical process used to determine the rate at which one quantity changes with respect to another. For example, the differentiation dy by dx expresses the rate of change of y with respect to x, where y is said to be dependent variable and x is said to be independent variable. Differentiation is of two types. First one is ordinary differential equation. It is used when a function depends on one variable. For example, y equal to x square, here y depends on x, y is said to be dependent variable and x is said to be independent. Second one, area of a circle, it is defined as pi r square, where area is the dependent variable and r is the radius, which is the independent variable. Partial differentiation we use when a function depends on two or more variables. Here, first example is z equal to x square plus y square. Z depends on two variables x and y, as well as area of a rectangle, that is we define a equal to length into breadth, where area is the dependent variable, depends on length as well as breadth. That means it depends on two variables. Now, function of two variables means what? A function say equal to f of xy here is said to be function of two variables, x and y is said to be independent variables and z is said to be dependent variable. Second example is z equal to x square plus 3xy plus y square. Here z depends on x and y. Function of three variables, it is defined as u equal to f of x, y, z, where u is dependent on three variables x, y, z. For example, temperature in the room T depends on the position x, y, z. One more example, y equal to x square plus y square plus z square. Y is the function of three variables x, y, z. Now, how to define partial derivative as well as what is the working rule to find the partial derivative? So, when a function depends on two or more than two variables, then partial differentiation is used. What is the working rule to find the partial differentiation? The first one, if a function depends on two variables, then how to get partial derivative? To find the partial derivative of z with respect to x, we differentiate z with respect to x, keeping y constant. It is denoted by deba z by deba x. It is the notation of partial derivative. And to find the partial derivative of z with respect to y, we differentiate z with respect to y, keeping y x constant. It is denoted by deba z by deba. The formulas of partial derivatives are same as those of ordinary differential equation. For example, if we are given a problem z equal to x square plus y square and we have to find deba z by deba x as well as deba z by deba y. So deba z by deba x equal to, we differentiate x only, we differentiate z with respect to x only and y we treat as a constant. So derivative of x square is 2x and y square will be treated as a constant and it will be written as it. When we differentiate z with respect to y, we keep x square as a constant and derivative of y square is 2y and the result is 2x square y. Above derivatives are called as first order partial derivatives. Now, first order, one more example of first order partial derivative. If we take z equal to e raised to x cos y, here two functions are there. One is exponential, second one is trigonometric function. To find deba u by deba x and deba u by deba y, First, we find dy by dx, keeping y constant, and we differentiate the function, exponential function with respect to x. As you all know, the derivative of exponential function is same as it is. So e raised to x का derivative will be e raised to x. Cos y, that is the function of y, will be treated as constant, and it will be as it is. Next one, to find dy by y, we keep the function of x as well as constant, and cos, derivative of cos y minus sin y, and the derivative will be dy by y equal to minus e raised to x sin. Next, one more example. If we have given u equal to tan inverse x by 1. So here, if we have to differentiate u with respect to x, we keep y as a constant, and we use the derivative formula, ordinary differential